deltas. It seems to form through silt, so little materials brought with the river to the mouth of the river, where it then accumulates, as head down, accumulates, and the sea is unable to remove them from there, so they accumulate them over time there. It seems to be millions of years. An example of an arcut or fan-shaped river would be the river Niger in Africa, which goes out and has formed a big delta, 200 kilometers or something, out, and the river is then fanning out. Or an cuspid shaped, the Ebro in Spain, that seems to go far out on more or less one track, and the bird's foot, the Mississippi in the United States of America, it seems to be a mixture, so going far out but also fanning out. According to geography by Jane Ferretti and Brian Grassley on the page 20.
And welcome. I'm trying to learn Potamology, today deltas, and after we've done that we're going to do stretching, and if you participate in the stretching then it's at your own risk. Some rivers have a delta, and this delta forms when silt accumulates at the mouth of the river, especially during flooding, and the sea is unable to remove it. There are three types of deltas. So first of all, the delta is something which is where the river is going into the ocean, and it is a process into the region out, do they say. Silt, I don't know what silt is, but it is some type of material. It accumulates at the mouth of the river, especially during flooding. Flooding of the river, or the storm bringing in the tide or something. And the sea is unable to remove it. Okay, I think it is the river itself creating it there. That makes sense. There are three types of deltas. Okay, I understand it that way. The river is transporting things with it, silt, in particular during flooding, and then it lets that all lay down where it goes into the ocean, and then it forms a delta, a greater area. So it's not just going out, but it delivers. Yes, it works like that. And it's not just going in, but it comes and lets then something drop down and more, and after some time there's then everywhere something lying, even higher than the river, and then the river is fanning in out. Now what do we have? The river Niger in Nigeria, arcuate or fan-shaped. Okay, the river Niger in Nigeria is then fan-shaped. So it's going out and transporting a bit with it, more until it has let the hill lying. During flooding, it lets even more there lying when it lets there something lying, and then it goes around it. And when the Ebro in Spain, that is a cuspid. That would be now, I guess, I don't know what has happened here. Okay, the next one, the Mississippi. Bird's foot example of the Mississippi. Now from the two pictures, I would say the Ebro, there has just happened that it has laid things down, silt down, but has just one outcome. And the Mississippi has them both. It has digged itself further down, but then also delta. Here is any explanation missing. Case study, how the Nile Delta has changed. Okay, another example is now the Nile in Northern Africa. Since the completion of the Aswan High Dam in 1970, huge quantities of silt have been trapped behind the dam in Lake Nassau. The Lake Nassau is not on the map. I would guess, I think the Aswan High Dam, it could be further down in Africa. But let's read on. There's somewhere along the long Nile, 5,000 kilometers or something, is a dam built, the Aswan High Dam, and since then there's less silt, some type of materials which are delivered with the river, trapped behind the dam, and down to reach the delta at the top, in Egypt, mostly, maybe completely. So consequently, the reason for the silt no longer coming in, not enough silt reaches the delta. This has the following serious consequences. Okay, silt is no longer reaching it, it's trapped behind the dam. What are we doing with the silt in there? The delta is getting smaller and people have lost their homes and land. Now I can't see it from the map, so what is happening there? The delta is getting smaller. Now it could make sense that the Mediterranean Sea is again through erosion or through whatever things, again digging the delta away. Why is it getting smaller? Why is it not just stopping as it extends as it has to that point? Okay, next point. Valuable nutrients are lost and fish stocks have gone down. Okay, in the river or in the Mediterranean Sea? Both possible explanations, as I would see them, would be that in the river there's no longer so much silt with it brought in and all these materials, and the fish and other things living in the river don't having so much anymore. Maybe also in the delta region and in the Mediterranean Sea. The soil is less fertile without the annual replenishment of silt. Farmers must now buy artificial fertilizers for their land. These are expensive and can cause pollution. Okay, the river Nile doesn't have so much silt or materials in it, therefore, when it is flooding, is it doing that still, even though the dam is there? If it's flooding, it's no longer laying so much fertile silt onto the ground, and the people who are doing the agriculture sometimes have to buy the artificial fertilizers to make the land again fertile. Let's see what is here. The Nile, the delta stretches approximately 160 kilometers in each direction. They mean it starts 160 kilometers into the land of Egypt and then fans out on 160 kilometers. The Mediterranean Sea is shallow and has no tide. It does not have enough energy to remove the silt. So the Mediterranean Sea, the first thing, it has just very little tide, just a few centimeters. It's very little. I don't know exactly, but it's very little. So it's just a little bit, let's say 1 or 2 centimeters, but it's marginal. Not enough energy to remove the silt, so such a tide would remove the silt. There is probably a tide at the Mississippi, at the Ebro, and at the River Niger. There's still a delta. And they're saying the delta is getting smaller at the Nile and the Mediterranean Sea. The sea doesn't really work out what I calculated around what could be the reason for it. We understand what they mean. There's little tide, therefore such a big delta with 160 kilometers, but if you look here at the River Niger, also 200 kilometers, that is probably going into the Atlantic Ocean, where it could form also such a big delta. Maybe that is the reason why it could grow so big, but it's not bigger as the of the River Niger. Okay, what is else in here? The river forms distributaries as it flows through the delta. Okay, distributaries. They said in the previous part, tributary rivers are rivers coming to it at a point of confluence. And distributaries seem to be the things if the river is fanning out. Okay, we have that. And then the river Nile carries a huge amount of silt as it approaches the sea. Before or after 1970? Or is it still huge? But if it is no longer enough for the farmers, that they have to buy artificial fertilizers, to describe it when the huge is not appropriately. The silt contains a lot of nutrients, so makes good farmland. Okay, we understood that. The silt has a lot of nutrients. People can make good farming, which they cannot because of Aswan High Dam, which is not on the map. Fish thrive in the... They just said valuable nutrients are lost and fish stocks have gone down. Okay, fish thrive in the nutrient-rich water. The silt which has accumulated over centuries has formed a flat and fertile delta, which is now a densely settled area. Okay, we understand that. This delta has formed over centuries, so over hundreds of years. Now, I would just guess it are maybe thousands of years or tens of thousands of years, maybe hundreds of thousands of years. I don't think that it looked dramatically different, let's say a few hundred years previously, let's say 400 years. Alexandria and all the other towns are way older than 400 years. Okay, it has formed over a long time, and it is a flat and fertile delta, and there are many people living because they can do very good agriculture. Okay, some things did we understood, other things don't really add up if trying to make sense out of them what was said here, but we understood a lot of things. If you were here for Potamology, you can go directly to the next part. Maybe we're going to go back and maybe it is enough what we understand to say a few things. We understood at least the thing with the fanning and the other two types. even though I can't explain them, because there was no explanation. We understood some things. If you were here for Potamology, you can go directly to the next part. However, we will continue if you stay here and participate in the stretching, und es werdet ihr auch. Even fiets in your and open one foot to the side and then with the up foot, with the heels and with the upper heels, and so on. Go as far as you can go, and bend back in again. This time stay down on the knees. And legs to the sides, lifting the arms up, and out go to the side. In middle, out to the other side. In, jump out down to one side, in, out one arm over, in and out the rib cage, out and back, and again in, out the other hand slides down, in, out one arm over, in and out the rib cage, and out and back, in the arms up, and out of the reach, in and out, in, out and down, and shoulder circles, back, up, and front, and down, and again back and front, up, back, and down, in the shoulders up, out and down, in and up, and the arms up, and reach always with one arm high up. Pretend to take an apple hanging high on an apple branch and turn it a bit around and harvest it. Legs to the sides, arms to the sides, reef in, and out over to one side. In middle, out to the other side. In, and out banging down. Reef again in, out one shoulder in front, in and back, and out the other one in front, back, and out into the hand down. Reef again in, out over to one leg, again in, out over to the other leg, in, middle, and cross the feet. Reef again, and out. Again, and out. In. Welcome slowly with the round back up at the top, backwards, shoulder to shoulder. The feet are pointing to the outside. And the arms up. And out, sink down, elbows against the inside of the knees. Reef in and straight now. And out come with a back up. Reef in. Out and down. In, straight up. And out in one straight line up. And sink down. Have a good standing leg. Heel of a normal leg on top of a knee of it. Reef in. And out and sink down. And up again. Change. Reef in. And out and down. Legs to the sides, reef in, come down, and out, open the chest to the sky. In, and out, another round, out, in, out, in, and close the legs. And it was the stretching. I thank you very much, and until next time.